Hello everyone, welcome to an algebra video tutorial about exponent properties. In this video, we're going to learn about the quotient property of exponents. Quotient is just a fancy name for division. So basically, we're going to look at what happens when we divide numbers and exponents and see if there's any properties or any patterns that we can notice as we do some division problems. So we've got three different problems we're going to look at. 3 to the 7th divided by 3 squared, x to the 5th divided by an x, and a to the 4th divided by a to the 4th. And we're going to use expanded form and what we know about exponents to see if we can notice anything in particular. Let's start with this first one here. 3 to the 7th divided by 3 squared. If I write it out in expanded form, 3 to the 7th is just 3 threes, 7 threes all multiplied together. So 3, 4, 5, 6, 7. And I'm dividing that by 3 squared, or 3 to the 2nd power, which just means there's 2 threes. Well, I know that 3 divided by 3, if I just remember division problems, 3 divided by 3 is equal to 1. So anytime I have a 3 divided by 3, I can rewrite that as 1. So let's rewrite this again a little bit differently and see what we have here. So I've got 7 threes on top, 3 times 3 times on the top, 7 threes all together, 5, 6, 7. And on the bottom, I'm going to put the 2 threes over here times 1 on the bottom. And again, it's just fraction arithmetic. Fractions multiply the numerators and multiply the denominators, so I can split them back up again. If I wanted to get back to this, 3 times 3 times 3, I can multiply the top to get 3 to the 7th. I can multiply the bottom to get 3 times 3 times 1 to get my 3 squared on the bottom. But now when I write it this way, look at what I have happen here. I have 3 times 3 divided by 3 times 3. Well, 3 divided by 3 is 1. And there's another 3 divided by 3 is 1. So it ends up just equaling 1 times all the rest of these 3's. These ones did not divide out. There's just division by 1. So I could actually rewrite it as 3 times 3 times 3 times 3. There's 1, 2, 3, 4, 5 left. Well, multiplying by the 1 and with 5 threes, I can rewrite that as 3 to the 5th power. Okay, so that was kind of a long way to do it, but basically we see that in expanded form, 7 threes on top, 2 on the bottom, some of my 3's divide out and some don't, leaving 3 to the 5th remaining. All right, let's do that again with the x's here now. So I've got x to the 5th, so there's 5 x's on top, x times x times x. One more, and I'm dividing that by just 1x. So I'm going to divide by 1x on the bottom. I'm not going to quite write it out fully like this, but I think you can kind of see that there's 1x, but if I put a 1 here, anything times 1 is itself, so I'm not really adding anything there. I do end up with an x divided by x, and just like 3 divided by 3, any number divided by itself ends up equaling 1. So right here, x divided by x just equals 1. And I'm left with 4 x's, left with x times x times x times x, x to the 4th over 1, which is just x to the 4th. All right, one more. Let's see what we got going on here with the a's. So I got 4 a's on top, a times a times a times a. And on the bottom, I've got a times a, 4 more a's on the bottom. Well, just like all the other ones, a times a divided by a, any number divided by itself equals 1. So anywhere where I have an a divided by an a is 1 times another 1 times another 1 times another 1. So really I can think of that as just 1 times 1 times 1 times 1, which is just 1. Okay, let's see if we can draw any patterns here. When I took 3 to the 7th divided by 3 to the 2, 3 to the 2nd power, I ended up with 3 to the 5th power. When I did x to the 5th power divided by x to the 1st power, I ended up with x to the 4th power. And when I did a to the 4th and a to the 4th, we ended up with just 1. That was weird. Where did my a's go? The pattern, when I'm dividing the same base, but with different exponents, the pattern is that we end up, if I have a base with to some exponent, again, this is any, b just represents any number and m represents any exponent. And if I divide it by the same base, but with a different exponent, the pattern is that my exponents subtract because I'm canceling each other out. There's certain numbers that divide out, and so I'm left with less of an exponent. So I can rewrite that as b to the m minus n power. So it's kind of like the opposite of multiplication. Multiplication, we combined all these multiplying numbers and variables together, and so we added the exponents. But when I'm division, my division, I'm canceling things out. I'm dividing to get ones. And so what happens is we subtract the exponents together. 7 minus 2 is 3 to the 5th. 7 minus 2 is 5. 5 minus 1 is 4, so I end up with 4x's, x to the 4th. What's funny here is a to the 4th divided by a to the 4th ends up being a to the 4 minus 4, which is a to the 0. We're going to get into this later, but basically I have no a's. I'm not multiplying by any a's, so there's just 1 as a placeholder. But there you go. That's the quotient property of exponents. You have to have the same base numbers. So I had to do 3 to the 7th and 3 to the 2nd power. I had to have x and x. I had to have a and a. They have to have the same base. But if they are the same base and we're dividing, I can subtract the exponents.